So panibagong video ulit for hydraulics at para sa video na to ay mag-solve o mag-compute ulit tayo ng mga problems about open channel. Sa mga di pa nakapanood ng video lecture ko tungkol sa open channel ay ilalagay ko yung link sa description sa baba. Tara! So ito yung problem. Problem number 3, a concrete circular culvert. So given na yung roughness coefficient para dun sa material ng culvert which is 0.012. So it has a diameter of 2 meters and is laid at a slope of 0.3%. During non-peak flow, so may binigay dito na condition, during non-peak flow daw, or sometimes we call it slow flow, the depth of water flowing on the culvert is 25% of the diameter. So yung full depth, which is represented by the diameter, ay 25% lang daw nun yung magiging depth ng flowing water during non-peak or low flow. So, determine the velocity and the flow rate if, so yung unang condition is if flowing full, then if non-peak flow. So, dalawa yung velocity and flow rate na i-compute natin dito. So, given the condition is flowing full and non-peak flow. So, ngayon ay illustrate natin yung ating problem. So, say meron daw circular culvert. So, usually ang circular or yung mga culverts pala ay yung ginagamit natin for conveyance na malalaking amounts of water or maybe wastewater or kadalasan storm water. No? So, ginagamit natin to bilang i-transport conduit for storm drainage systems. Ang tinutukoy ko naman ay yun dito sa Philippines. So, usually yung kanyang material is made up of reinforced concrete. Anyway, ito yung ating circular culvert daw. So, may binigay naman na condition dito, if flowing full or during non-peak flow. So, simulan muna natin sa flowing full. So, kapag flowing full, ang i-consider natin ay yung full depth para dun sa open channel. So, ito yung full depth which is represented by the diameter. So, diameter is equal to 2 meters. So, para sa ating solution, so, since given na rin naman yung n as 0.012, also, given na din yung slope at 0.3%. So, ngayon, itong 0.3% ay in terms of percentage pa, no? Hindi siya in terms of the ratio between rise over run. Pero pwede natin siyang i-convert doon, no? So, tanggalin lang natin yung percentage. So, gawin natin ay divide lang natin into percent, no? Or 100 yung ating slope. So, that is divided by 100. At ito na yung ating magiging slope. That is 3 times 10 to the negative 3. It is also equivalent to 3 times 10 to the negative 3. So, unitless na yan. At store natin siya sa A. Shift, store, A. So, and pero na tayong slope at na-store na natin siya to A. Ngayon ay take natin yung solution para dito sa ating first condition. So, for our first condition, if flowing full, so kapag flowing full, no, ang compute natin ay yung velocity daw. So, gamitin ko tong formula na Manning formula. At, consider natin yung hydraulic radius for flowing full. So, kapag flowing full, R is equal to A over P. Wait lang, baguhin ko lang pen color ko. That is, R is equal to A over P. So, ngayon, since flowing full yan, ang gagamitin nating formula dito ay yung formula natin for the cross-sectional area of a circle and for the circumference of a circle na full revolution. So, yun ay pi d square over 4 and pi d So, gagawin natin ay cancel out natin to. Cancel out din natin yung pi. At ang matitira lang dito ay d over 4. So, ito na yung gagamitin nating hydraulic radius. d over 4. So, ang magiging working equation na natin would be v is equal to 1 over n times d over 4 raised to 2/3 and s raised to 1/2. So, ganito lang gagawin nating solution, lalo pa kung sasabihin sa problem that the liquid is flowing full. So, input na natin yung ating mga given. So, that is 1 over n, 0.012 multiplied to d, which is 2 over 4 raised to 2/3 and s, which is the stored value at a, raised to 1/2. So, yung velocity for that is, input natin sa calcu. So, that is 1 over 0.012 multiplied to, so that is, 2 over 4, so 1/2 na to, pero input pa rin natin, raised to 2/3 and s. So, yung s natin is the stored value at a pala. A raised to 1/2. Ayan. So, nakalimutan ko pala multiplication operation dito. Anyway, ito yung computed na velocity. That is 2.8754. So, 2.8754 meters per second. So, ayan. Gawin natin ay store natin to sa A. Store pala natin sa B. Since may na-store na pala tayo kanina sa A. Shift store to B. Okay. So, kasi computein pa natin yung flow rate Q. So, para sa Q, that is our favorite formula, Q is equal to AV, since ang consider natin is flowing full, ang gagamitin nating formula for A is pi d square over 4 times velocity. That is Q is equal to pi times 2 squared over 4 times velocity. That is the stored value at B. So, yung value ng Q, pi times 2 squared over 4 multiplied to B, alpha B. Ayan. So, yung Q is 9.0332 yan, cubic meters per second. Yan. So, ito na yung para sa first condition. No? Nakompute na natin yung velocity in meters per second as well as yung flow rate in cubic meters per second if yung condition is flowing full. So, ang sunod naman nating i-compute ay kapag ang flow is during non-peak flow. So, ngayon ay itry naman natin yung second condition, which is if non-peak flow. So, during non-peak flow daw, ang ating fundamental daw na condition is that is 25% daw of the total depth, no, which is the diameter. So, 25% of D or also 0.25 D. So, ngayon, to illustrate that, say, ito yung nga yung circular culvert. So, kung 25% yun, syempre, lampas siya ng kalahati. Mas mababa sa kalahati. Ibig sabihin, nandito. So, ngayon, if nandito siya, ito daw ay 0.25 of D. Since 2 yung ating diameter times 0.25, that is 0.5 meters. Kasi yung 0.5 nito ay 1, then yung kalahati pa nun is 0.5. So, yung depth ng flow is 0.5 meters. So, ibig sabihin, from bottom, no, or mula dito sa, kung tawagin na invert, hanggang dito sa dito sa surface ng flowing water ay 0.5. Yun namang distance from surface hanggang dito sa center ay 0.5 din. Ayan. So, ngayon, compute natin yung velocity and yung flow. So, same pa rin naman. Ang formula natin is man pa rin. It's 1 over n or 2/3 s raised to 1/2. Ngayon, kung titingnan natin, given na rin naman yung n at saka yung s. Same lang din yung gagamitin natin. Kaya lang, yung r ang hindi pa natin na-compute. So, since r is equal to a over t, or the cross-sectional area of flow over the wetted perimeter, no, ay kailangan natin makompute tong dalawang to. Problema nga lang, may iba na yung ating cross-sectional area of flow. Ngayon kung titingnan nyo, baka kasi isipin natin na 25% siya nung depth or ng total depth, which is yung diameter, ay 25% lang din siya nung total na area, as well as 25% siya nung total na perimeter. So, hindi ganun yung mangyayari, no? Kasi kung i-compare natin, once na ma-solve natin yun, hindi sila magkakaparehas. So, mahirap kasing i-compare yung, say, square, no, sa circle. Okay? Kasi kung iti-take natin yung 25% nito, say, hatiin natin siya into 4 parts. Wait lang. Ulitin ko. Hatiin natin siya into 4 equal parts. So, see, 1, this one is 2, and 3, and 4. At saka itong sa circle, hatiin natin siya into 4 parts. Ngayon, itong area na to, area 1 for this square, dito sa portion na to, ay same din, no, ng area dito sa 2 kung siya ay equally divided. Wala tayong problema doon kahit is 0.5 natin dun sa total na cross-sectional area, okay lang. Unlike dito, iba yung cross-sectional area para dito sa first portion na to, iba yung cross-sectional area para dito sa second portion. So, pwede natin mapagparehas ito sa taas at saka sa baba. Kaya lang, magkaiba yun nasa gitna, no? At saka dun sa nasa upmost at saka sa nasa bottom. Kasi nga, hindi siya linear, no? Curve siya. At nagbabago, no? Or iba yung variation pala nung area, no, habang bumababa tayo with regards to depth. Kaya hindi natin gagawin yung i-correlate natin siya into the percentage, no, and multiply natin dun sa total cross-sectional area. May iba. Kaya kukumpitin natin siya using formulas din for area. So for A, for the total area, A is equal to, so ngayon, hindi natin mako-compute directly itong portion na to. Okay? Hindi natin siya mako-compute directly kasi wala naman tayong formula, no, na straight, not unless siguro kung gagamit tayo ng ng integral calculus. Pero kung gusto natin itong i-compute using geometric formulas, pwede nating hati-hatiin by portion yung mga areas, no? So, pwede nating kunin yung area ng sector. So, ulitin ko lang. Kunin natin yung area nitong sector, no? Which is, ang ating reference ay itong circumference na to or itong arc na to. So, gagawin natin ay kunin natin yung sector, which is ito. Ayan. Pero ito lang, cross-sectional area lang na ito. Itong shaded part na to, yung iti-take natin. So, ngayon, since kinuha natin or tinik natin tong buong sector na to, yung area na i-consider natin, which is para dito sa area lang or sa cross-sectional area of flow, pwede nating sabihin that that area is equal to the area of the sector, which is itong buong parang pizza pie na to, minus yung area nitong triangle na to. Okay? So, re-illustrate natin. So, ito yung sector. Then, hatiin natin siya sa dalawa. So, para dito sa area or sa A na kailangan natin, kunin natin yung area nitong buong sector na yan, which is represented by A sub S. Then, i-minus natin itong excess, which is itong triangle na to. So, i-denote natin siya as A sub 2. So, yun. So, expand pa natin yung formula. So, para sa area ng sector, re-illustrate ko lang. Para sa area ng sector, that is the ratio between the included angle, which is represented by theta, over full revolution 360 times yung formula for area pag full revolution, that is pi r square. So, in terms of r na lang natin. Minus yung area ng triangle. So, ang formula natin for the area of the triangle is 1/2 BH. So, ito na yung magiging working equation natin. So, ngayon, bago natin makompute itong buong to, meron tayong mga unknown dito. Yung r given naman eh. Kasi yung r, alam natin na yung r ay equivalent to 1 meter. Kasi ang diameter natin is 2. Pero, itong theta, di pa natin alam. Yung h, itong h na tinutukoy, which is ito. Alam na natin to eh. 0.5 siya. Or 0.5 meters. Kasi itong depth din na to is 0.5 meters. So, ayun. Try natin computein yung theta, no, which is yung unknown, as well as yung b. Hindi pa natin din alam itong b na to. O yung base para dun sa ating triangle. So, let's try to compute. Simulan natin sa angle theta. Ngayon, kung hahatiin natin to, itong sector, yung mapo-form natin na right triangle dito, para mas madali yung ating solution, is equivalent to the base over 2 as the opposite side for the included angle theta over 2. Then, itong side na to is the radius. Ito, radius siya, which is 1 meter. So, para dito naman sa h, which is equivalent to 0.5 meters, makakompute na natin yung value ng theta since may given na naman na dalawang sides, no? Hindi na tayo mahirapang mag-solve. So, given yung ating hypotenuse, no? So, which is 1, and given din yung adjacent. So, adjacent over hypotenuse. So, that is adjacent hypotenuse cosine. Cosine theta over 2. So, theta is equal to 2 times the inverse cosine 0.5 over 1. So, equivalent ng theta is inverse cosine of 0.5 over 1 times 2. That is 120 degrees. So, ngayon yung theta na to is 120 degrees. Okay na tayo doon. Theta is equal to 120 degrees. So, ang sunod naman ay yung value ng B. So, hindi pa natin alam yung B. Yun na lang yung unknown para dito sa ating formula. So, take natin dito sa right triangle na to. Since B is the opposite side, B over 2. So, given maalin dito sa R o doon sa radius o doon sa hypotenuse o dito sa adjacent. So, gamitin ko yung sa adjacent side. 0.5. So, this is opposite over adjacent. That is tangent theta over 2. So, yung value ng B ay input na lang natin sa calculator. Since na-compute na naman natin yung value ng theta. So, that is tangent ng theta over 2, 120 over 2. So, 60 na yun. Pero input pa rin natin sa calculator. Then, equals, shift solve na natin. That is B, or let's say that's X, alpha X over 2 over 0.5. So, yeah, positive number naman to. So, yung X o yung value ng base, ang value ng base natin is 1 pala. 1.732 meters. So, na-compute na natin yung base which is 1.732 meters. Ayan. So, siguro hindi ko na to store sa calculator. At, ayan. Erase ko na to. Since na-compute na naman natin yung kailangan natin para mabawasan yung ayan. So, para mabawasan yung nakalagay dun sa screen natin. So, that is A is equal to theta, which is 120 over 360 times pi r, ri1 square minus 1 half b, 1.732 over, times h pala. Ang h natin ay 0.5. So, input na natin sa calculator para makompute na natin yung value ng cross-sectional area. So, that is 120 divided by 360 multiplied to. So, lagyan ko pala ito ng parenthesis. This is multiplied to pi, shift pi times r, which is 1 squared minus yung sa triangle that is 1 half. 1 half times 1.732 multiplied to 0.5. So, ito yung cross-sectional area of flow. So, gawin ko, store ko to sa, store natin siya sa B. Okay? Panibagong store tayo. So, A is equivalent to 0.614 square meter. Okay? That is stored at A. So, para naman sa wetted perimeter, P, that is, kunin natin yung circumference na para dito lang sa arc. Okay? Dito lang sa arc na to. Ay, yung makakompute natin dyan ay hindi, ayun, ay gagamitin natin pala yung included angle which is theta. So, gamitin ulit natin yung ratio between dun sa theta at saka dun sa full revolution, 360, times multiply natin sa area, sa circumference pala ng full revolution. That is 2 pi r, not square, 2 pi r. So, T is equal to 120 over 360 times 2 pi times 1. So, ito na yung ating wetted perimeter. So, wetted perimeter is 120 over 360 multiplied to 2 times pi times R, 1. So, yung wetted perimeter is 2.094 meters. Okay. So, ngayon, ang gawin natin ay store natin to sa B. Sorry. Sa C pala. Sa C. Store natin to sa C. Whereas ito palang A ay yung stored value natin at B. At compute na natin yung value ng R. That is A over P. Also equivalent to B over C. So, ayun. Shift, store, C. Anyway, kahit nga hindi ko na siya i-store eh. At i-check lang din natin yung values. So, the stored value at B is 0.61 and the stored value at C is 2/3 pi. So, ayun. Kunin lang natin yung ratio between B and C. Alpha C. At ito na yung ating hydraulic ratios. So, gawin natin, store ulit natin to sa D. Shift, store, D. Okay. R is equal to 0.2932 meters and stored to D. Ayun, so makumpit na natin yung velocity. So, para sa velocity, that is V is equal to 1 over N is 0.012 multiplied to D raised to 2/3 and S, which is the stored value at A raised to 1/2. So, check ko lang din kung nakastore pa rin dito yung slope na 3 times 10 to the negative 3. Anyway, nakastore na siya kaya pwede na natin directly input. That is 1 over the stored value at A. N pala. 0.012 multiplied to stored value at B raised to 2/3 and S times A raised to 1/2. Ayun, so ito yung na-compute natin na velocity. Okay. So, yung na-compute natin na velocity is 2.0147 meters per second. So, gagawin natin ay, since na-compute na natin yung flow velocity, ang sunod naman natin i-compute ay yung flow rate. No? So, using our favorite formula, Q is equal to AV. So, na-compute na natin yung A, no? That is the stored value at B. At multiply lang natin dito sa na-compute natin na velocity, which is 2.0147 meters per second. So, yung makakompute natin dito na Q ayan, ay 1.2374. So, 2374 cubic meters per second. Ayan. So, ito na yung computed na flow rate. So, hindi natin pwede basta-basta i-multiply sa 25% itong na-compute natin, no? Para sa condition of flowing full. Kasi kung gagawin natin yun, say, yung ating full na flow rate, no? 9.0332 multiplied to 0.25. Ayan, so, malaki yung difference, no? Ito. Compared dun sa 2 point something. Ayan, at yun lang para sa video na to. Sana may natutunan kayo at see you sa next video. Thank you so much.